This conference will now be recorded.
Hello, everyone. My name is Elizabeth Klein. I am the acting GOZAR Data Operations Manager. Happy Halloween and welcome to the SBC, or the Satellite Book Club, session number 213. Today's presentation is Midwest Winter Satellite Successes and Challenges. Will be presented by Patrick Ide, Science and Operations Officer from the NWS Weather Forecast Office in Duluth, Minnesota. Our facilitator today is Chauncey Schultz, Science and Operations Officer from the NWS Forecast Office in Bismarck, North Dakota. Just a few reminders before we get started. This session is being recorded. Please mute your microphone and turn off your webcam. The question and answer section will be after the presentation. Please, I would encourage all attendees to please post your questions in the chat room during the presentation, and they will be fielded through there at its conclusion. If you are logged in under an alias account, please either sign in with your full name or specify your full name when asking a question in the chat. We are always looking for future presenters. Please contact the Tower S team if you're interested in presenting. The training team can help create training materials if they're unavailable. Contact Ross Van Thiel for more information or questions on that. I'd like to extend my thanks to the OCLO, the GEO and LEO programs, and our facilitator, Chauncey Schultz. Patrick Ide has been the SUE at NWS Duluth, Minnesota since January 2020. Previously, he worked for nearly 12 years at NWS Bismarck, North Dakota, and was a SCEP at NWS Grand Forks, North Dakota. Patrick has developed multiple reference guides and given several presentations at workshops and conferences, as well as training webinars on GOES 16 and 17 topics. Patrick, welcome back to the SBC.
Thank you very much. I appreciate that. Just a quick mic check that we're sounding all right. Alrighty, sounds good.
We can hear you.
Alrighty, so we will get started. I'll drop my camera off just to make sure that it worked. But yeah, so what we're going to go over here is really what has really been worked well in satellite, and where are some of our challenges, especially in regards to winter for the upper Midwest, and probably by extension everywhere else. So next slide if you want there, Kashad. Yeah, so I think it's easy sometimes to get caught up in what is the next derived product or the next advancement in our satellite. But I think what we do try to preach to our staff, especially with mesoanalysis, is, you know, how about we keep it simple first, right? And let's just bring up a nice big long loop, in this case just a still of visible or just a simple RGB, because I think we probably don't get ourselves credit enough for, wow, look at everything we can see here on the day cloud phase RGB. If I remember correctly, this was from my time in North Dakota, and I believe this is like a late winter, early spring day cloud phase RGB. But I could name, how many things can we rattle off here, right? We can see the snowpacks in the green across much of North Dakota, the stripe of green where it just recently snowed across southwest Minnesota into the Twin Cities. We get a sense of the different air masses. The clouds and the snow is more yellow and orange across northern Minnesota and Ontario because of the contributions of the infrared, compared to it's green across southern Minnesota. So that gives us a sense of the air masses, right? We can see, that those first attempts at springtime convection with the bubbling up and the glaciation and the yellowing and oranges in the shallow convection from Montana into South Dakota, and we get, just where are we lacking our ice crystals as well across North Dakota into northwest Minnesota. So I think it's important that a lot of our successes are just keeping it simple, but really spending our time in really taking all the value that we can extract from something as simple as this. And yes, we'll go into some more derived products in special cases, but let's keep it simple. Next slide, Prashad. All right, we're gonna keep it simple again, and this is the dry yellow color curve, and hopefully the loop kind of smooths itself out. This is from a mid-December event from a couple of years ago. And what we're really watching here in this case is we're seeing convection starting to erupt in the dry slot where we'd expected, where there is more instability across southwest into south central Minnesota. And that's all, on a direct path to my neck of the woods on the western end of Lake Superior. And what did that essentially do? Well, we erupt that convection, we release a bunch of diabatic heating, and we then lead to the intensification of the trough and what turned out to be, a band of quite heavy snow moving up the Twin Ports up the North Shore. But again, it's not necessarily that we have to have these, an ML or AI. Let's just keep it simple and really doing it right in our analysis on just our base imagery. And what this can do is just catching on to that convection that's starting to erupt across southwest and south central Minnesota. Okay, what is that downstream implication once it moves off into the colder air in northern Wisconsin, northern Minnesota, and begins to interact with our kind of larger scale conveyor belts in the trough, right? So there's a lot to extract from there. So I think we're just really starting to see a lot of our successes in that. And sometimes just keeping it simple and making sure that we have a great understanding of the foundational conceptual models from our base imagery and kind of our base RGBs. Next slide. Almost a carbon copy. All right. So what about today? This All Hallows Eve, right? Well, that looks pretty similar, right? So it's quite apt that we're giving this winter satellite presentation when SBC literally just issues a heavy snow MCD right at the beginning of this presentation for Minnesota. But the same thing, it's doing things right. And so what are we focusing on? Well, there's that dry slot, at times the dreaded dry slot, right, which can really mess with our forecasts. We've seen a few flashes of GLM in that dry slot where we have our instability, and we see then the trials starting to form and all that dynamic cooling to switch us over from rain to snow at the surface. And we see that, in this case, in the trial, and by putting all those conceptual models together, we see the jet identification as well, with very fast flow from the central Mississippi Valley up into the Great Lakes. So, next slide. Now, it is a different set of challenges in the winter. So we get beautiful imagery, right, of convection from the summer, but it's a different set of challenges in the winter. I think the number one thing is that it's simple, is that there's just less light. There's less light and less time in the light, especially at the latitudes where I'm sitting right now, right? So you just don't have as much tools in the toolbox, especially say from an RGB perspective, because we lose the light, we don't have a lot of it, right? So a lot of the specialized RGBs and things that we can do for more summer and warm season applications, just a little more difficult, right, in the winter, right? Our geostationary cloud top trends and trying to deal with a lot of the microphysical processes. The problem is, well, today, right, underneath all that cloud cover, well, I really care about what's going on at like 850, 900 millibars, but that's completely socked in by the upper level cloud cover. So how can we try to get at that? That'll take some more microwave sensing applications. And then another thing that we're going to touch on a couple times is just the training on cold season satellite strategies. It's been something that we've tried to do and emphasize at our office, and it takes time to build that muscle. And we see large focus, and rightly so, on our convective and warm season applications and fire applications. But how much focus and where is it a gap that we need to fill on some of our colder season strategies? All right, well, how good are you at identifying all the cold and the warm conveyor belts and the trials and dry slots and its implications? And how good are we at understanding some of the microphysical processes that we can pull from the satellite when we're able to? Next slide, good job. All right, so where are the opportunities, and we'll kind of give some examples of it. I think there's definitely some opportunities in more winter-centric fused products. We certainly have a lot of that on the warm season, but There are aspects that we can, maybe try to bring out by fusing both satellite and NWP. We have also, this is a big one for me on lake ice condition, and then the snowpack from my time in North Dakota and the blizzard capital of the Northern Plains is snowpack condition characteristics, right? And then, kind of the golden thing that we are really going to help us is our low-level thermodynamic and moisture retrievals, and that's not easy even in the summer, right? On some of our new cap soundings. So, all right, let's step through a little bit of this. Next slide. All right, here we go. When is this? This is a late November image. Not too far off from what we're seeing today. Cyclone across the Mid-Mississippi Valley, an expansive stratus layer on the day cloud phase RGB. And, well, we all know that it's all in that cyan color. That's all liquid, at least liquid topped, if not mostly super cooled or just liquid water. But, well, where is the freezing drizzle threat there? And where isn't it, right? So can we fuse some types of NWP and also satellite characteristics to get us, like prop freezing drizzle or prop snow squall, right? Akin to kind of prop severe. So I think that would be a help okay, we have this stratus layer that extends all the way from, in this case, Arkansas all the way into Ontario, right? Somewhere in there is a freezing drizzle threat. So how can we take some of our low-level dynamical fields and thermodynamic fields and give us some sense of a derived product of, okay, where is that? Kind of like we do for prop severe, or what is prop snow squall, right? For we see some glaciation and some shallow convection there across eastern Missouri. Not saying that it's a snow squall in this case, but again, can we fuse thermodynamic and kinematics with some satellite presentation to give, say, like prop snow squall, right, to help us inform snow squall warnings. Next slide. All right, this next one's going to be the big one, right? And it's something that we're trying to put a lot more emphasis on is winter mesoscale analysis. It has seen great, resurgence, this resurrection, right, in the past, 5 or so years, especially with remote mesoanalysis initiatives. Great success, really helps us to land the forecast. And on a day like today, when I'm literally staring out my office window at a mess of a winter situation, we got to land the forecast. So a big part of that is how do we strengthen our muscle for winter mesoscale analysis? And satellite is a big component of that, right? It can tell us a lot about, where's my conveyor belts. That's going to help us understand what our conceptual models are. Where can I get a sense of vertical motion, divergence, frontogenesis? It's really something that we're just starting to scratch the surface on, and that we're really starting to try to incorporate more and more in our operations. Not only to take the messaging out the door, but also to inform ourselves, right, for our own internal IDSS. Some things that we probably don't take advantage of enough, I think, are the derived motion winds. And, at least in my office, that's so. And I think that's something that, that I need to be better about too, is I think that's a data set that kind of falls off at times. And so how do we incorporate that in our mesoanalysis as well for satellite? Because that can tell us a lot about the dynamics and kinematics. So next slide, good shot. Touched on this, but obviously when you have a mixed mess out there in the winter, boy, if we all were able to have a better sense of what the moisture and thermodynamic fields were the first 5,000 feet, that'd be great, right? So again, this is not just a cold season challenge, it is an all-season challenge of how do we improve our thermodynamic and moisture retrievals from down low, right? And it's probably even, it's certainly important in the summer for buoyancy. And boy, it plays a big role in the winter, where plus or minus a degree means plus or minus 5, 6 plus inches of snow, right? So just a challenge that we have. Next slide. This is an example as we come to the next slide of that when we've also seen when at first glance the satellite presentation is not matching up, at least on first glance, with your conceptual model of the expected event. So this is cloud top phase for a weakly forced event. This is a late December 2017. What we're looking at is the snow ice band. So anywhere that it is much brighter is where we have liquid top or super cool cloud top phase, or just liquid if we're probably down in Texas. Anywhere where it's darker is obviously where we have ice crystals. Again, based on the sensitivity of the 1.61 snow ice band. All right, so at first glance, what's the difference in the stratus from Texas all the way up to Minnesota? So let's go to the next slide. And what we're seeing is, well, what do you know? It's cold, right? It's cold in Minnesota. Temperatures in the single digits. And it's snowing. Okay, not surprising, but why is the snow ice band showing all super cooled water? Why isn't it just ice, right? We're really cold and it's snowing. All right, so what's going on here, right? So this is something that I worked with Dan Baumgartner-Sue in La Crosse with. So if we go to the next slide, we'll kind of show the same thing in just a couple different flavors. This next one will be infrared, and the infrared is definitely cold. We're sitting at -20 or colder based on the color curve. If we go to the next slide, this is actually going to be the cloud top phase product. So the cloud top phase product, rightfully so, is showing a bunch of green when we get to that. And that is all super cooled or mixed water, right? So why, in an Arctic air mass, when it's snowing at the surface, why are we getting super cooled water indications both in the individual bands and then also in these derived products? So the next slide, we'll take a little deeper dive into this. So we're at Chanhassen in this upcoming sounding, and we're saturated, in the stratus layer of -16 to -22. That should pretty much be all ice, right? Go to the next one. It is a sounding from Aberdeen, and a tad warmer on the saturation on the next slide at Aberdeen, where we're saturated between -14 and -18. Okay, so a little warmer, but for the most part, that should all be ice crystal, or all be ice crystals. So, all right. So let's actually explain kind of why. It took us a little bit to dig up why this was. So next slide, we're able to track down a paper dealing with Arctic air mass cloud phase stratification. And basically, what we're looking at is cloud radar and high spectral LiDAR. And we'll really focus in on a couple things, where the vertical motion is, and then the differences in the cloud phase, so the top and the bottom part of that image. So we see that in these Arctic air masses, the cloud type is very highly regulated by where the inversion is, right? So that essentially forces our maximum vertical motion to be more mid-cloud, more in the mid-cloud, except than compared to the top. So if we go to the next slide, which kind of continue this kind of conversation of this, is that vertical max more in the mid-cloud is initiating ice there, and that falls towards the surface and it glaciates the cloud from the mid-cloud down. But that really lack of vertical motion right at the base of the inversion actually leaves kind of this very thin layer of supercooled water. So this is all to say that sometimes what we're seeing on satellite and the observations aren't necessarily what we expected right away, but it leads us to this deeper understanding of these microphysical processes that in this case are happening in an Arctic air mass. Okay, next slide. All right, we're going to switch gears a little bit and focus on essentially the ground. So, and I know this is at the heart of Chauncey and Bismarck and the Grand Forks office of the ever big conundrum of what the snowpack is and how loftable is it, right? I remember from my days at Bismarck, I would literally just go take a walk in the NWS Bismarck backyard, kick the snow, and say, that's pretty crusted, or I don't know, maybe it'll blow. I can kind of kick it around. So when we're dealing with ground blizzards, and especially purely ground blizzard, really no falling snow, one of the biggest sources of uncertainty in that decision is the snowpack condition. Is it a glacier that's not going to move? Is it a bunch of fluff? Is it somewhere in between? I remember working an event with Chauncey where it basically turned into like a severe weather event where the crust was progressively breaking across North Dakota in an Arctic, behind an Arctic front, and we were just chasing this ground blizzard, and it was like we were, dealing with this convective outbreak and a squall line moving across the area. And then there's also hydro implications here. What's the characteristics of the snowpack? Is it about to unleash its water and release it or not, right? So next slide. And snowpack characterization and temperature, it's ripe for especially polar satellite applications because it's not necessarily time sensitive. We don't need this every 10 minutes, right? So, but if we could get this, a really, daily or at least multiple times a week snapshot of what that snowpack characterization is. Can we get age? Can we get thickness? Can we temperature, right? That's something that continues, I think would be a massive help to, especially a lot of plains offices in dealing with snowpack characterization for ground blizzard applications. All right, next slide. And we probably go to actually 2 slides ahead. We can go to the next one then. Good shot. There we go. All right. And there we go. So this is, it doesn't show up. Okay, it kind of shows up. So one of the biggest successes we had, and this is a giant kudos to Carl Jones, Tony Grafenauer at NWS Grand Forks and their collaborations with the University of North Dakota, is we're looking at the day cloud or the day snow fog RGB, and the ability to actually detect blowing snow in that RGB and the horizontal convective rolls that are essentially the depiction of the blowing snow. So if you look closely across the Red River Valley, which essentially is the Minnesota and North Dakota border, we see this fuzziness, or at least in this loop. It's a little bit better in the native slide deck. But we can see these horizontal convective rolls, kind of this lightish pink that is moving down the Red River Valley. If we go to the next slide, which is a still and hopefully a little bit better resolution, what we're seeing is actually we're able to see the extent of the blowing snow in this RGB. And okay, we're trying to figure out why we can see that, right? So, horizontal convective rolls in this Arctic outbreak, we're gusting to 45 knots at -11 Fahrenheit at Fargo, North Dakota. So definitely funneling of the winds down the valley. But why are we able to see the blowing snow on satellite looking like horizontal convective rolls, right? So it's really, the theory is that we're ice crystals are being lofted and shattered. And so we're getting likely a difference in reflectives in kind of those shattered ice crystals aloft. So this has been a big win, especially for the Grand Forks office and applications as well into the Bismarck office for being able to detect blowing snow on these RGBs. And I think they developed their own blowing snow RGB from that as well. So, all right, shifting gears again, next slide. We're going to go now to a little bit more of my neck of the woods and the Great Lakes and ice applications. So once it comes up, just a beautiful MODIS picture. It's beautiful, right? And able to get a great depiction of the ice. And one of the biggest things that we've taken advantage of, and on the next slide, is the synthetic aperture radar or SAR imagery for the Great Lakes. And it's able to give us just exceptional detail, not only in its depiction of ice, but also in its microwave retrieved winds over the lake. So on the next slide is probably one of my favorite images. And this is a normalized radar cross section, and it's all microwave, right? So it's able to generally see through the clouds. And this is from my neck of the woods. There is the Twin Ports of Duluth Superior just off on the left. We go up the Bayfield Peninsula into the Apostle Islands. And so we are able to gain a ton of information of the ice characteristics on the lake. So in this case, we have northwest winds, Arctic outbreak, building ice. Everything that's fuzzy essentially is slush. So we kind of get this slushy, fuzzy ice. We're able to know and confirm via webcams that this kind of stripe of white, that's packed chunks and pancakes of ice, right? So that is much different than the depiction near the Twin Ports on the left of this younger ice with cracks in it. We can see ice building up within the islands, the Apostle Islands. And we can see because of the winds, the ice being infected and blown down in the wake of blown down and around the Apostle Islands. We can see, Schwamingen Bay, which is this older, thicker ice. Well, that's older, thicker ice. It's not going to be movable, right? And also gives us implications, again, for lake effect. Okay, where do we have cracks in the ice? Well, if we have cracks in the ice, there's still going to be heat transfer from the lake to the air. So, but there's also another great application and example of this. If we go to the next slide, one of the things that we struggle with, as always a big question, is, are we going to get lakeshore flooding? We have especially long duration gales, northeast winds down western Lake Superior. Are we going to flood Canal Park in Duluth? So what we see here is, this is an example from, I believe, 2023, where here is the normalized radar cross section. And essentially what we see is we're able to see that we have some ice along the south shore initially. And it is just kind of slushy ice. And so it's going to be mobile. It's going to be on the move, right? And so what we eventually see is this fuzzy depiction in pretty much the end of the loop, where all that ice has been pushed towards the Twin Ports and is stacked up. So it looks really fuzzy. And then we confirm on the webcams that we just loaded up ice. So it doesn't matter that it was a long duration gale with giant waves. We knew that this ice was going to infect down the south shore and build up at the head of the lake and be essentially this giant dam, right, to block all that wave energy, so we're not going to get lakeshore flooding. So essentially, it was on the next slide, it was a great example of holding with a lakeshore flood watch, not going to a warning, as we waited to see what would happen with the ice, because we knew it was going to infect down. We've had good interactions with cryosphere winter campaigns. Again, how do we build up our ice intelligence? Great coordination with the National Ice Center, because, this happens in the spring where ships get stuck largely in Lake Whitefish Bay when they're trying to start up in the spring. So, all right, next slide, just kind of tie it all together. So, we've seen a lot of successes in our winter applications for satellite, especially as we apply the foundational things in winter mesoanalysis. Things that would be nice haves, right, are fuse products like we see in the warm side of the house. Some fuse products with NWP and satellite on the cold side of the house. Snowpack characterization. I mean, that's always, you do that and you're gonna, Grand Forks and Bismarck will love you. So, and then the big win would be low-level thermodynamic moisture retrievals. I mean, no big, surprise there. I mean, that's going to be an all-season thing. So, on the last slide is just my thank you and my email and some plate ice from the North Shore. So that's all I got.
All right, thank you so much, Patrick. That was a fantastic presentation. Really gives me an idea of what's to come once winter arrives here any day now in the Northern Plains. So yeah, great, fantastic presentation. We'd encourage everyone to hang on here for the discussion that we're going to have now. We'd especially encourage participation from anybody out there in the field forecast offices, regional headquarters, and others, of course. We also would encourage everyone to go ahead and change your view setting right at the top of your GoToWebinar to active cameras. It probably says everyone right now, right, for the default view. If you change that to active cameras, that'll help you be able to see Patrick and I, and maybe from the peanut gallery, throw things at us if you so choose. Emily's going to be posting a link in the chat room for any feedback that you might have on this Satellite Book Club session, and it looks like she just posted it right now. We also want to mention that in a week from today, next Thursday, November the 7th at noon Eastern Time, William Skip Dronin, who's with the NOAA NESDIS OSPO Direct Service Branch, he'll be providing an overview of the NOAA data collection system hosted on GOES-R and GeoXO. We'd also encourage attendees, all of you, to contact the Towers S team, of course, Kashad Bowman and Emily Maddox, for any questions about the Satellite Book Club or for any configuration of satellite products. And I know we saw a few of those mentioned that are going to be coming up in future updates in the chat at the side. So as I said, we'll open it up for good discussion and questions that you might have. We encourage a lot of discussion, and we already have one from Curtis Seaman at CIRA CSU. Patrick, he's wondering if you get any freezing spray off Lake Superior.
Absolutely. It's one of the things that is almost a tourist attraction, actually, to see the ships come in just absolutely coated, right? So 100% we get freezing sprays is a big issue for us. And that gets to, especially, if we look at, the ingredients for that, if we look at the synthetic aperture radar and the microwave wind retrievals that we're able to get off that, that's a big help because it's data sparse. Soon they're going to pull all the buoys on Lake Superior because they don't want them crunched in the ice, right? So for sure we do. And it's something that we forecast. What we do actually do heavy freezing spray warnings as well. So you get a 1,000-foot ship with a very blunt bow, and it doesn't take much to make a ton of ice. And even for them, it can quickly become a concern. So absolutely we do.
Yeah, certainly high impact stuff going on there. I can see the IDSS applications for sure. I'm curious, how often do you get those microwave imageries, like the radar one for sure? That's something I'm not admittedly very familiar with in our part of the world.
Yeah, you should get it over Lake Sakakawea there, Chauncey, right?
Yeah,
so,
right.
Right, it might help. So usually we get them about 2 passes today, I believe, on the 0s and the 12Zs that they come in, and it's essentially must-read stuff, especially for me every day. Because it's just cool looking, right? And then it has an impact on, okay, where are we going to close our marine zones, right? Because they're completely iced over. So if they're iced over, we don't need to issue a forecast for them, right? It's just there's nothing, right? So, but then it also helps again with an understanding of where it's ice, but if there's cracks in the ice or slush, well, there's still heat transfer there. So we're still going to be able to generate lake effect snow, right? Until we have completely, coated the entire thing in a solid sheet, there's still going to be ice transfer there. And then it's, some things that, in the kind of the higher level of DSS, in which we're still trying to sort out where exactly our lane is the ice rescues, right? And, where is the ice potentially cracked or more mobile, where you're going to float ice fishermen out to sea, essentially, right? So again, we're trying to find our way, and there's kind of some differences in how offices handle that across the Great Lakes. But the microwave wind retrievals are great because it really helps to give us soon to be nothing but ship offs on the lake, and so it really helps to fill in the gaps. Plus, it is what's cool.
Yeah, no, that absolutely makes sense to me. And you touched on some other questions that I had, which is how often the forecasters are looking at it. And, it makes sense to me that there's that much influence on a lot of your DSS. I was wondering if you were going to show us an ice flow with ice fishermen on it. I know that's a pretty frequent thing there, and I could see that application as well.
We usually once or twice a year start to float things off. So.
I can understand that. We had a great question come in from Scott Lindstrom. It was something that was actually on my mind as you were going through your presentation. Scott's curious if you have any office training reminders or frequent reminders even to change the band 13 enhancement curve seasonally, or about changing the daylight, as daylight changes, the RGB composite options to adjust for that lamentable lack of sunlight this time of the year. And I agree, Scott, it's become quite lamentable for me just in the last week, I think. So any thoughts on that, Patrick?
Yeah, no, I'll take this as my reminder, right? So it's definitely something that we um, that is at times in the back of our minds, but I don't think we probably talk about it enough. Like, the past couple of days, like I have, adjusted my water vapor down a little bit, right? So it's definitely a great reminder and something that, I need to put in my own fall training, right? Of how do we take advantage of it? Just like, in the summertime when we, mess with that visible to get squeak out a little, 10 more minutes of the visible satellite, right? It's definitely something that would be really helpful. I mean, we know it is. And I think, it's just the forecasters like, I have made this procedure, I'm going to use it year round. And so it doesn't always work like that, right? So it's a great reminder, and it's something that that should just be, part of like, well, Chauncey and his wonderful like tidbits of seasonal training, right? Like, just needs to be a little tidbit reminder. So.
Yeah, it's a great point. It's something that I'm very guilty of. I thought of it, as I said, as you went through your presentation as well. And like you said, Patrick, I think as forecasters, we're just so set in. We have this procedure saved, this perspective saved, and we go to it without thinking, how can we eke a little bit more out of that? And as you said, that is a big challenge this time of the year. I'm curious if you think that's the biggest challenge to some of these winter satellite operations, or if there's something else that comes to your mind as what would be the biggest challenge with satellite and winter weather, and even as applying it to mesoanalysis as you talked about.
Yeah, so well, I'd make a plug first. Like, there could be if the color curve could dynamically change based on the temperature, that'd be nice, right? So, but that's beyond my capability. Yeah, I think talking to other students, I think some of the biggest challenge is almost like we talked about, just getting back to the basics, right? So if I bring up just this long loop of water vapor, or if I bring up this long loop of the day cloud phase RGB, how well can I pick out the conveyor belts? And then taking that a step further, if I can pick out the conveyor belts, okay, but then do I have a downstream understanding of the conceptual model that leads to heavy snow, the conceptual model that leads to P-typing? So I think a lot of it is that we've had this big emphasis on summer applications, and we see very similar corollary to this in dual pole. That CDR arcs and hail and all, right? But well, there's a lot of dual pole that falls off the table in the winter, and we're trying to put more of that dual pole back on the table. And I think it's a very similar thing in winter satellite of just getting back to the basics and that foundational understanding of, as we've marched off into all this probabilistic and ensembles, have we left some of the basics behind? And if we left some of the basics behind, you're not going to be able to see that stuff in satellite. So I think it's just bolstering that capability of folks. Can we understand the basics of cyclogenesis theory and conveyor belts and some kinematics to apply these conceptual models and do that well, right? And it's the same thing with radar, right? So back to the basics. And if you don't have a great understanding of CDR, you're not going to have a great understanding of this higher level application. If you don't have a great understanding of conveyor belts and just the base satellite imagery, you're not going to be able to extend it. So I think that's where the biggest challenge is.
Yeah, no, I totally agree with you. One of my other questions really was going to be, how do we build up the confidence for all of us in doing a lot of these things? Is it reps? Is it, and like I think you alluded to, Patrick, it's probably a little of everything, right? Starting with those conceptual models and maybe those reps. I don't know if you have any other thoughts on, training and resources, strategies, and things like that may be out there.
Right. So if you could develop some, Chauncey, that'd be great. But yeah, no, I think it's all about reps. It's just about talking about it. It's just being intentional in your conversations and in our interactions with the staff. I'm sure we all have some operational chat room, right, at our office. Like, hey, did you see this? And here's, let's pull that apart. Or if we do an after action, let's go back to some of the satellite. Maybe we didn't catch it right away in real time, but let's go back and let's, what was that? What did we see there in satellite? What, foundational, conceptual model can we apply to that? And you do that enough and over again, and then it catches on. We've seen that, in all things. If we just kind of demonstrate it, you got to demonstrate it multiple times, and and it just kind of becomes more innate. I mean, yes, it'd be great to have, really dedicated, focused winter satellite curriculum. That'd be great, but it just starts organically in our conversations in the office and just kind of poking around these things. And for ourselves, for the students, like, oh, I got to be brushed up enough too, right? So, making sure I got a handle on this as well. So that's kind of my take.
Yeah, I totally agree. And I see Brian in chat, mentions that too. Yeah, we need more training in some of the conceptual models and tying them back to that. We've got just a couple more minutes left for any questions. If anyone's got any other questions or comments, whether they're sort of high level, like we've been talking about the last few minutes, or in the more technical details kind of thing. And maybe while folks are thinking about that, Patrick, I'll sort of throw one at you that's, again, a little bit bigger picture maybe. What do you think is the biggest opportunity going forward with winter satellite applications?
Right. So that's a big question, right? I am a satellite user, so I just take the good stuff that's made, right? So I think we've seen there's a few things that come to mind, and it's, I think, stuff we touched on, from some of the polar, applications, for, say, snowpack characterization, whether it be for blowing snow or hydro, where we don't need it updated on a 5-10 minute, we don't need a mesoscale sector for snowpack characterization. But what can we tease out on, to a higher level on the characterization of that snowpack for all those very important and life-threatening applications, especially ground lizard, right? I think it'd be really cool to see more fused products, right? There's certain, and it's like akin to Prof Severe, right? There's a lot of things that satellite can bring to the table, and there's a lot of things that NWP can bring to the table. And how do we, marry that up to a greater extent and take the best of both worlds from NWP and satellite? Those are some initial things that come together. I mean, obviously, if we can get that very last bottom right, for on those retrievals, that'd be great. But hey, that's cost money, right? Right. So we understand that, we get that, but I mean, that's certainly something as we go into the next generation of satellites and just being able to get those thermodynamic moisture retrievals, especially the very lower levels, to a little bit more certainty, that'd be a big help.
Yeah, I totally agree. And you mentioned going outside, kicking the snowpack, trying to decide if it's going to blowable or not. I think advancements in that. I know Bill Line mentioned a few in the chat. One that's polar orbiting, and then a new RGB that's coming. And then just thinking of the last chat from Steve Miller, just talking about the day-night band and how we can maybe distinguish snowfields versus clouds at night too. Lots of opportunities there. I think the machine learning aspects to maybe take some of the ideas you presented here, Patrick, about fused data sets could be big advancements. And I'm sure a lot of the smart folks that are even on this call probably advancing those in the years to come. So yeah, thank you so much, Patrick, for the excellent follow-on discussion as well. I don't see any other questions for us, so I'm going to turn it back over to Liz.
All right, here I am. Thank you very much. Patrick, thank you for presenting at SBC today, and thank you, Chauncey, for leading the discussion. Thanks to everybody else for joining in online. And as previously mentioned, please remember in a week from today that Skip Dronin will be here from OSPO's direct service branch to provide an overview of the NOAA data collection system hosted on GOES-R and GeoXL. Thanks, everybody. Happy Halloween.